Again, welcome to lecture 11-3. Our topic is implicit differentiation. So again, our main objective is how to find the derivative by using the implicit differentiation techniques. Also, how to find the slope of tangent by using also implicit differentiation. So up to this point, we always write a function as y equal to f at x. In this case, we are defining y as an explicit function, y equal to f at x. However, not all equations involve x and y can be written in the form of y equal to f at x. So we need a new technique for their derivatives. So an example is, for example, if we are going to find the derivative of y squared equal to x, that would be very difficult to solve it explicitly, to find the derivative explicitly. Or we can write y squared equal to x as y equal to plus or minus square root of x. But we know plus or minus square root of x, y equal to plus or minus square root of x is not a function. Why? Because if we test it with a straight line, we are going to get, if x is 2, that means we get both positive 2 and negative 2. And that will make it not a function for us. The square root of negative 2 is not a real number. Or we also can graph it, and we'll see that example soon. So y can give a square root of x, and we can say y equal to negative square root of x. But then finding the derivative of dy dx at a point on the graph of y squared equal to x will require us to determine which of these function price before taking the derivative. Because if I know y squared equal to plus or minus square root of x, which gives me y equal to positive square root of x, and also negative square root of x. From here, we say y squared equal to x. So y will give me positive or negative square root of x. Now, to find the derivative, since we have a positive and negative value, we don't know where to start from. So the best way of solving this problem is using the implicit differentiation techniques. So we will see an example here. So here we say using implicit differentiation to find dy dx for y squared equal to x. What will happen is that we are going to find the derivative of y squared. We take derivative of both sides. So this will give us dy dx y squared equal to dy ds x. Then since y squared is more or less the dependent variable, we are going to use the chain rule. So we get a derivative of y squared will give us 2y dy dx. And derivative of x will give us 1. Again, let's look at the solution. So first we have to, implicit differentiation means we have to take the derivative of both sides. So we have the dy ds of y squared, dy ds of x. Now, since we are using dy s squared, and y is an independent variable, we can set this as, this will give me y squared is 2y. Then the chain rule of dy dx equal to 1. What we, in short, we say, yeah, we have to use the chain rule because dy ds y squared equal to dy dx x. We know y, again, is the dependent variable. So the derivative of dy dx y squared will give me 2y multiplied by dy dx. And the derivative of x is 1. So finally, our answer will be 1 over 2y. We take the 2y to the right, cross the equal sign, and that will divide. Now, B said we should find the slope of the tangent at the point 4 and 2, and also 4 and negative 2. So now we know the equation. Dy ds is 1 over 2y. So when I'm going to find a tangent of any point, I have to use the derivative of the function. So first, the question was, Let's look for the derivative of y squared equal to x. We use implicit techniques here, differentiation techniques here. We take derivative of both sides. So we get dy dx 2y. Derivative of y squared is 2y, dy dx. And derivative of x will give me 1. So dy dx will give me 1 over 2y. Now to find the slope, I'm going to point, since I don't have no x value in the equation, I'm just going to point only the y value. So the first is 4 and positive 2. So which means y is positive 2. So I plug in 2. 2 times 2 will give me 4. The second is 4 negative 2. So I plug negative 2, which will give me 2 times negative 2 is negative 4. So negative 1 over 4. So that will be again the final solution. Then when we plot the graph, just to check, we can see that this is not a function. Why? When we draw a vertical line, a function means anytime we draw a vertical line, we have to have only one intersection, not 2 or more. So since this is 2, this is not a function. The next question, they say we should write the equation of the tangent to the graph of x cubed plus sy plus 4 equal to 0. They give us a 0.2 and negative 6. So here we are writing the equation of the tangent. So first thing we need to look for is, again, find the derivative of the function. Here they say note that the second term is the product of x and y, which is this very term. So this makes it impossible to do it explicitly. We have to find it implicitly because both the dependent and independent variable are multiplied by each other, s and y. So we have to use an implicit method, not explicit. So note that the second term is the product of x and y because we are assuming that y is the function of x, and because x is a function of x, we must use product rule to find dy dx xy. So just to find only xy is a product rule, and since y is independent variable, product rule we have to, there's no any constant value here. These are two variables. So we have to use the product rule, which will give us derivative of x times y plus derivative of y times x. And that's what we have here. Derivative of x, which will be 1 times y, so y times 1. Then derivative of y times x, which will give us dy dx. So finally, our answer will be x times dy dx plus y times 1, which is 1. So this will be plugged in x1. Then we know the derivative of x cubed will give us 3x squared. Derivative of 4 will give us 0. So next we can see derivative of x cubed plus derivative of xy plus derivative of 4. And then we know this will give us 3x squared. We find this already, derivative of xy using the product rule. Then derivative of any constant value is 0, equal to derivative of 0 is 0. So we do our transformation of formula, open the parentheses, 3x squared go to the right side of the equal sign, it becomes negative. 0, we take it out. Y also is positive. When you cross the equal sign, becomes negative. S is multiplied by dy dx. So when you cross the equal sign, it's going to divide. So finally, our derivative of dy dx will be negative 3x squared minus y over x. And then finding the slope, remember they gave us the point, x and y. So we plug in the x value and we plug in the y values, and the slope is negative 3. Now, if I know the slope, I can find the equation of the tangent line using the formula y equal to y1, sorry, y minus y1 equal to m, parenthesis s minus s1. So y1 and s1 will be the value of 2 and negative 6 here. So we plug in y1 negative 6, s1 positive 2 here. When we simplify the equation, our final answer will be y equal to negative 3x. We can graph this equation again. When we graph it, we solve the equation by this. And we can see the graph. And also y equal to negative 3s is the red. It's a linear. Now, next question, they say we should find the y ds for each of the following. So we have a natural log sy. So this is again another product rule because we have two variables equal to s. But the first thing we're going to do is take the derivative implicit. We have to do implicit because s times y. It's not explicit. So we have to take the derivative of natural log sy, and we're going to use the product rule, and also derivative of 6, which is the constant rule 0. So we extend this first. Natural log sy is the same as natural log s plus natural log y equal to 6. Then we take the derivative. This is a very good idea. Again, either way, we can solve the problem. But see, if we use the product rule, the expansion will be too long, which means we have to find the derivative of natural log x times natural log y plus derivative of natural log y times natural log x, which will be again very long. And we're going to have a natural logs all over the equation. So the best way, I think we should use the sum rule by expanding the multiplication. We know the log product rule gives us, when we expand it, we get, so natural log x plus natural log y is the same as natural log sy. When we are combining sum, we get product. When we are combining differences, subtraction, we get quotient. So this is more better because natural log x will give me 1 over x, natural log y will give me 1 over y, but again, y is our dependent variable, so chain rule, we also get the y dx. So we do our formula transformation, and we take the 1 over x first out, is positive, so when you cross the equal sign, negative. Then y is dividing, when you cross the square sign, it's going to multiply. So finally, our answer will be negative y over x. Now in the second equation, example, also the same thing. We have to take the derivative of both sides individually. So we can see the derivative of 4x squared will give me 8x. Then the derivative of y raised to the power sy will give me y raised to the power sy times the derivative of xy, which we, again, here we use the product rule. And that's what we have here. So we get derivative of x will give me 1 times y plus the derivative of y will give me 1 dy dx, so times x. So we get x dy dx plus y. Then derivative of 6y will give me 6 dy dx. So we do our transformation. First, we remove the parentheses. Then we just do transformation. I'll bring the 6 dy dx down here. And my goal is to combine the y dx separately. So that's what we did here. And we take the y dx out of the parentheses. And we can see that we get 6 minus xy raised to the power xy. So this means our final answer will be the y dx will give me 8x plus y raised to the power sy divided by 6 minus x sy. So another example here for application. Here they say, suppose the demand for a precision incorporated headphone is given by the following, where P is the price per set in dollars and S will be the hundreds of headphone set demanded. Now find the rate of change of the demand with respect to price when 1900 sets are demanded. So first, what comes to my mind about rate of change means we have to change our equation to a derivative of it. So rate of change of demand with respect to price S is the SDP. So we find the derivative. Now here we are looking at 10,000 S plus Y. So we find the derivative of this. And first we rewrite it. Then we find the derivative of this. We get minus 2 S plus 1. Then negative 2, negative 3 will give me negative 3. I took the 10,000 out since it's a constant. Derivative of P will give me 1. And remember, we still have the derivative of the P here, and we have the SDP. Then from here, we just do transformation. Finally, the SDP will give us x plus y, x plus 1 cube divided by negative 20,000. Then we leave the answer as it is. Now, rate of change with respect to price is $19. So we plug in 19 for x, and that will give us negative 0.4. So that will be the conclusion of, again, our lectures for implicit differentiation. So what this price means, negative 0.4 said, the result means that 1,900 earphone sets are demanded. If the price per set is increased by $1, then the expected change in demand is decreased by 40 cents or something, negative 0. It's a negative, so it's decreasing. So that will be the conclusion. Again, if you have a question, you can send an email or you can reach me on my office number. Thank you. Bye. Wish everybody the best.